Now let us know how to assign binary input, binary output, or LED. So we'll cancel this one, cancel also this one, open configuration, binary module. This binary module is used for assigning binary input, binary outputs for any bay unit and also central unit. And from the configuration here we'll find the LED, this one, to assign the LED for any bay unit also or the central unit. First we'll choose any bay unit here, for example this one. We'll find here this one is the binary input and this one is the binary output. If we came here for the binary input, we can make new signal. We'll find here some general signals: busbar protection, breaker fail, end fault, disturbance, bay protection, and so on. So for example, for the busbar protection, you can choose, for example, bypass check zone, any signal, for example, and press OK. He will tell you no auxiliary contact or one auxiliary contact, so you will take one auxiliary contact. And here you will check which binary input is needed, binary input number 1 or 2, 3, 4, and so on. Okay, and this one generate event at leading edge. This default, leave it as default, don't change this one. And here you have user defined text. Is a user defined text. Here you can put the name according to your binary input as you like, according to your scheme, but the relay put it as default by the same number here, by the same address and the same name of the binary input. He put it as a user defined text. Okay, and then if you go back here, he will tell you apply first. Okay, apply, overview. Here you will find the binary input is added here. Where is the binary input? We added here. Yes, binary input number 8. And also you can delete this signal. But there is some difference in these 3 binary inputs. If you delete this one, and we need to edit. What's this binary input? This binary input is for the disconnector, the bus disconnector and circuit breaker status. So we removed one of them. So we'll press new signal here and we'll choose general signal. We'll find here isolator or breaker position. Then we'll find here only one option available because the other 2 options are used here, the other bus disconnector and the circuit breaker. But if all of them is not available, for example this one, also delete this signal, and also this one, delete this signal. Then you can press new signal, and from the general signal you can use isolator or breaker position. So you have here 3 options: D13, D613, D614, and A604, the 2 bus disconnectors and the circuit breaker. So if you choose this one and press OK, he will ask you one auxiliary contact and you give him only the closed signal. It means if the closed signal is not on, it means the disconnector is open. Or 2 auxiliary contact, so you can change, you can give him the open signal and the closed signal. So for example, the open signal is number 1 and the closed signal is number 2. Inverse signal, it means you need to make the binary input is active low. By default it's active high. If you make invert signal here, it means you are making it active low, and then you can give name for this binary input and then press apply. If you go here back again, overview, you'll find this binary input is available here. And then by the same way you can add for the other bus disconnector and for the circuit breaker. Actually you'll find this configuration almost right, but you have to check this one with your scheme. Is that for disconnector D613, the open status is binary input number 1, closed status number 2, and so on for all other binary inputs. Here for binary outputs, you can also press new signal and choose any signal, for example trip, and then press OK. He will tell you this one latch output, no, I need it reset delay. How much the time for resetting? Reset delay means this one is when the signal is coming on, the output contact will be on, and when signal is off, this signal will last for some time delay. If you put it 0, it means this output is a straight output. Okay, and here if the output signal are blocked system wide, it means if you already give a command for blocking, it means this signal should be also blocked or no. If this signal is used for tripping You have to do really block this signal. And if this signal is used only for indication or for signal sent to the SAS or something, you have to don't block this signal. Only alarm, for example, only alarm. And then choose your output contact from here and give it name here, and then press apply, and then come here overview. It's available here without any binary output. Okay, so you can choose with binary output number 1. But what's the benefit of making this one without binary output? Why the relay giving me this option? How I can put signal without binary output? Actually, this one helped me for the LED. Why? Because if you open here the LED for this, the same bay unit, which is security building, and you'll find here 3 signals. If you press new signal, you will find here the signal which is inputs, which is already including in the inputs, and one is used in the output. What's the meaning of this one? It means if any signal not available in the binary inputs or binary outputs, it means you cannot use this signal on the LED. The LED is not opening for you all signals. No, you have to add this signal in the binary inputs or binary outputs without assigning this signal, with a binary input or binary output. Just make it free, like this one. Sorry, cancel. Like this one, free, and then this one will appear for you there. For example, if I make new signal and I will put busbar protection, for example, busbar protection blocked. Okay. And I will not assign this one with any binary output, and then press apply. If I open here configuration LED for security building, and I make here new signal, I'll find here the outputs increased by 1, which is called busbar protection blocked. If I cancel this one and then I came here and I remove the busbar protection blocked, this one, which is the busbar blocked. If I remove this one, delete signal, this one, delete signal, yes, and then I go to here the LED again and I make new signal, I will not find this signal available here anymore. So to put LED, the signal must be included in the binary inputs or the binary outputs, even you are not using this one, or you are not assigning this one with actual binary input or binary output. Now we know how to assign binary inputs and binary output for any bay unit or the central unit by the same way, but the difference here is to know which signal available in the bay unit and which signal is available in the central unit. For example, the differential current alarm on the bus zone or the check zone. This differential current alarm is common for bus zone, not related to one bay unit. It means this signal available in the central unit, not in the bay unit, right? And also many signals, and we'll see this one during our test. So we can close this one again, and now let us start by our format. We'll find this one here, this one's the data. Here, for example, the set ratio is 3000. So let us imagine that we change our setting to all of them, to all set ratio for all bays to 3000 ampere. Okay, first we'll start by the measurement. We'll inject the 3 phases with neutral, with 0.25 angle 0, 0.5 with angle 240, and 0.75 with angle 120. So the neutral current calculated will be 0.433 angle minus 30 degree. Here, as we know, the measurement of this CT to be included in the busbar protection, at least Q1 or Q2 must be closed. If both bus disconnectors are open, the CT measurement is not included in the bus zone measurement. So here we will start with the bays on the busbar 1A and 2A. For example, we will start with bay AD01. For the first time, we'll close only Q1. So the bay unit measurements will be included in bus zone 1A. If you close the Q2, the bay unit measurements will be included in bus zone 2A. So this one is the calculated values according to our injected values, which is 0.25, 0.5 and 0.75, and this one is our neutral calculated value as a primary side. And then I will go to the bay unit and check the value for the measurement of the currents and the angles. And then from the program I can open here view analog input measurements and then choose my bay unit that I'm injecting at, which is AD01, and check the measurement for my bay unit, the 3-phase and the neutral. And the protection zone measurement also, you can open here view protection zone measurement. And as I told you, if Q1 is closed, I'll find bus 1A has some measurements. If I open the bus 1A inside this one, if I open view protection zone measurement, it will be appear for me bus 1A, bus 2A, bus 1B and bus 2B. If I open analog input measurement or protection zone measurement, this one will appear for me like this way. If I open the zone measurement, this one analog input measurement, this box will come for me, the three-phase current and the neutral current with the angles after I choose which bay unit I need. And for the protection zone measurement, it will be open like that. I have 4 bus zones, and I will check which bus zone I need. For example, if I'm closing Q1, so it will be appear, so the bay unit measurement will be available in the bus zone 1. So if I open bus zone 1, he will tell me which feeder measurement is included in this bus zone, and he will tell me the differential current, the restraining current and the stabilizing factor for each phase separately. So if I go again to my measurement here, so I'll find the ID and the differential and stabilizing current and the stabilizing factor, which is the slope for each phase separately. And if I close Q2, I'll find this measurement is available in bus bar 2A, not in bus bar 1A. I will do the same test for all other bay units or other bays available on bus bar 1A and bus bar 2A. And there is one quick test here. It checks that if you close Q1 and Q2 together on the same test feeder and the feeder under the test, you will find in the protection zone measurement here, if you open this one and protection zone measurement, as I told you, you will find one page which is called which will give you bus bar 1A, bus bar 2A, bus bar 1B and bus bar 2B. In case of Q1 and Q2 is closed, you will find only 3 bus zones now, bus bar 1A and 2A in one bus zone, and bus bar 1B and then bus bar 2B. So we'll go back here and we'll check that if I close Q1 and Q2 together for any other feeder on the same section A for bus 1A and 2A, I'll find also bus bar 1 and bus bar 1A and bus bar 2A become only one bus zone. And I will do the same measurement for all bays available in bus bar 1B and bus bar 2B. These measurements for all bays except the bus coupler and bus section, because as we will know later that the bus coupler and bus section not depending only on the isolator status but also depending on the circuit breaker status. Then we'll go to here, we'll find the differential current alarm test. The setting for the characteristics of the bus zone, IK minimum is 3000, and for the check zone also 3000. I differential supervision is on, and the setting is 5 seconds for the time delay. And for the differential current value is 5% of IK minimum, and for the check zone also 5% of IK minimum. I will choose here continuing operation for the bus zone system response, and for the check zone bypass check zone protection. Why? Here if I open the system response, for the differential current alarm I need to continue in operation to don't block the bus bar protection. I don't need this one, actually I only need alarm, and this one if I need to check the response of the system, but actually now I need only alarm. For the check zone protection, I have here 2 options: continuing operation and bypass check zone protection. I have only one element, you can say, or you can say I have only one output, which is called check zone bypassed. This output will come with me if the differential current alarm is detected on the check zone, and if I choose this option, bypass check zone protection. But if I choose continue in operation, there is no any signal available to give me indication that there is a differential current alarm on the check zone. Otherwise, I have to send to ABB and ask them for the signal which is called check zone differential alarm, and they will add it and then send me back the file. But now, as default, I only have signal called a check zone bypassed. I have to check or choose this option. So if I go back here, I choose this one, continue operation, and this one, bypass check zone protection. Now I have to assign LED and output contact with the check zone bypassed, and one LED and output contact with the differential current alarm. As I told you, for the check zone, this one common for the substation, and for the bus zone, this one common for bus zone 1A or 2A, 1B, 2B. It means these two signals are not related to each pay unit separately, so these signals are available in the binary input-output module of the central unit. So if I go back here, close this one, configuration, binary module, I will open the central unit. In the output context, I'll find here differential current alarm. If I remove this one, or remove, for example, delete, then you can make new signal. You check here, differential current alarm. Okay, I need this one is a reset delay, and will be with output contact, for example, number 1, and then go overview. I'll find this differential current alarm. Also, I need to the signal which is called check zone bypassed. Here, bus bar block. Here, check zone bypassed, and I'll tell him okay. And for example, binary output number 3. Then this one available differential current alarm and the check zone bypassed. If you check with me here again, you will not find check zone differential current alarm. But if you need this signal, you can check from the manual the address for this signal and send it to ABB and ask them to add this signal for you. So close this one and then go to configuration, LED, choose the central unit and add here new signal from the outputs, which is called differential current alarm. Apply, and check zone bypassed, apply, then cancel. Here is asking you the mode of this one is latched or state. We'll choose it state. We don't need it latched, state. Apply, then okay. Then close this one. Go back here. Our setting, as we said, here setting, bus bar protection. We'll put this one 3000. This setting is 5%. And here also this one 3000, and this one is 5%. Apply. For now, for pickup and drop off, we need to reduce this time, which is minimum 1 second. Apply, and also for this one it's also 1 second, then apply, okay. Then we will open file and download to protection system, send the file to the central unit. Then we'll go to back here for bus bar zone or bus zone 1A, bus bar zone 2A, bus zone 1B, and bus bar 2 bus zone 2B. We'll choose any bay unit, for example here AD05 and here AD17. Any bay unit is okay for me, and then I will inject on AD05 on only red phase. I will increase the current gradually and wait for 1 second. As you know, the alarm will come after 1 second, so I will increase gradually, and every time when I reach 0.05 I will wait for 1 second to check the alarm coming or no, and then increase until the LED coming on the central unit, and then I will go down drop off for drop off. The same for phase yellow, the same for phase blue, and this one the same, this one included in bus zone 1A because Q1 is closed. Then I will open Q1 and close Q2, and then you'll inject on AD17 where Q1 is closed, so this one including bus zone 1B and then bus zone 2B. Then I will go back to my setting bus bar protection. I will increase this time again to 5 seconds, apply, and for the check zone also 5 seconds, and then also apply OK, and then file, download to protection system, and then I will inject on phase R double the value for this differential current alarm, or triple value, and check the time delay for this one on red phase, yellow phase, blue phase. The same if Q2 is closed, and the same for the other bay unit on bus bar 1B and bus bar 2B. Then also we'll do the same but for the check zone, and our indication is the check zone bypass, and our output contact, which is also a check zone bypass. We'll get also the pickup and drop off and the time delay for this alarm. Then after checking this one, we'll find here bus bar protection differential current. Okay, here we will start to check our characteristic for the bus zone and a check zone. Okay, the stabilizing factor here, the slope is 0.8, and the minimum value IK minimum is 3000 for the bus zone. And for check zone, this one also is a slope is 0.2 and the IK minimum is 3000. But during testing of bus zone, put the setting of the check zone 1000 ampere, and during checking the check zone characteristic, put the IK minimum for the bus zone is equal to 1000 ampere. As we know, the tripping logic, depending on at least one bus zone characteristic is achieved and the check zone characteristics is achieved. So during testing of this one, you have to reduce the setting of the other one. Okay, our indication LED, which is called bus bar trip L1, L2, L3, and our output contact for tripping time delay, which is called trip. Okay, trip bus bar trip L1 or L2 or L3, this one is a common tripping, so this one is available in the central unit. But actually, as we know, that the tripping command is issuing from the is issued or should be issued from the bay unit. So you'll find this trip is available in each bay unit. So each bay unit under test, you'll use this output contact from the bay unit, and from the central unit you can use this 3 signal to tell you the tripping on phase L1 or L2 or L3. So we'll go here, configuration, binary module for the central unit. In the output contacts, we have to make new signal, and for the bus bar protection, we'll find bus bar protection trip L1. Okay, we don't need output contact for this one, and bus bar protection tripping L2 and bus bar protection tripping L3. So these 3 signals available here, so we can use this one on the LED. And also you have the bus bar protection trip here for this one, where in the general signals, trip bus bar zone in the general signal, and then you can choose trip bus bar zone of 1A or 1B or 2A or 2B. This one will be give you more information that there is a tripping on bus bar phase L1 on bus bar 1A or bus bar 1B or 2A or 2B. So also you can assign these signals, but during our test we only need to check the pickup and drop off and tripping time. But actually this one also has to be assigned to tell you which bus bar protection has a problem. Okay, so we'll assign this one also, new signal bus bar 1B, new signal bus bar 2A, new signal bus bar 2B, and then apply. Then I'll go to the bay unit under the test, which is for example security building, whatever, anyone, and I go to outputs. I'll make new signal here, and from the bus bar protection trip here, I'll find this tripping signal. Maybe this one is already available, so we'll see here, it's called trip. This one is already available with the address 21 2110. It's already available here in the format 21110. This one is issued when there is a busbar protection trip or breaker fail stage 2 from other bays. So we'll use this one as output contact. So it's already available in output contact, and you will find this signal available for all bay units, available also on the same output contact for all bay units. Then I'll make view configuration LED, and for the central unit I will use here, for example, LED number 11, new signal. This one from the outputs I have busbar 1A trip, busbar 1A trip, busbar 2A trip, busbar 1B, busbar 2B, and then busbar trip L1, busbar trip L2, busbar trip L3, then cancel, and I'll make all of them are state not latched. Then apply, then OK, and the bay unit under test now, which is security building, for example, already the trip is available as LED, but actually I don't need this one, I only need the output contact. No problem for the LED for the bay unit. Then file and download to the protection system. I'll go back to my format again. Now I'm testing the bus zone, so the setting for the check zone should be 1000 ampere. So I'll come here again, setting, also for busbar protection. Here, this one, I'll put this one 1000 ampere, and okay, apply, and for this one 3000, it's okay, apply, okay. And for the system response, as I told you, we'll make both of them continue in operation, apply, okay, and also file download to protection system. Then we'll come here to our table here. We'll find we'll inject on on the bay unit, each bay unit separately. So we are going to test the IK minimum only. We are not going to test the slope for IK minimum. So we will inject for each bay separately. Okay, so AD01 will close Q1. So if I increase, then I will inject on phase R, and I will increase gradually until the value going to 3000, which is second reside is 1 ampere. In this case, I will get the indications that busbar trip L1 on the central unit, this LED, and I will find bus zone 1A tripped, okay, and then go gradually reduce the value until the drop off. The same for phase yellow, the same for phase blue. Okay, then we need the tripping time. We'll inject 5 times the backup value, or 5 times IK minimum, as the tripping characteristics is tripping characteristics time between 20 to 30 milliseconds at 5 times of IS. What's the meaning of IS? IS means I differential over IK minimum. So if the I differential 5 times of IK minimum, the tripping time will be between 20 to 30. So I will inject 5 ampere from the second page of the Fraser, and I will check my tripping time for phase L1, phase L2, phase L3. I will do the same test for all bay units. All bay units. Okay. Okay. Then I will come here. For the check zone, I have to go to the setting again. Setting, busbar protection, and for the bus zone, I will make this one 1000. Apply, and for the check zone, I will make this one 3000. Apply, okay, and then file the download to protection system, and then I will come back here to my format. I will increase the current gradually on L1, and then on L2, and then on L3, and reduce gradually to get the drop off and the tripping time delay. Actually, this one's the same idea of the bus zone. During increasing here, actually the bus zone is already achieved. Bus zone IK minimum, which is 1000, means 0.33. So when I'm increasing the current and I exceed the 0.33, it means the bus zone is tripped, and the relay is waiting for the check zone to trip then in this case the central unit will detect a fault on bus bar, for example 1A, because Q1 is closed, and the central unit will send a trip command to the bay unit connected to bus bar 1A, which is AD01, and then the bay unit will issue a trip command which is through this output contact, which is called trip, and this output contact is wired to the circuit breaker tripping circuit. I will do the same for AD02, AD03, and so on for all bays in my substation. Now we need to start to test the differential current slope, which is the K. Okay, our bus zone stabilizing factor, which is our slope, is 0.8, and IK minimum is 3000, and for the check zone it's 0.2, and I differential or IK minimum is 3000. Our contact is the same, so we'll go back here to the setting, bus bar protection, we'll put this one also 3000. Okay, press apply first, and here also we'll put 3000, and then apply, then OK, then file and download to protection system. Actually this one for the slope test, if you use any two bays on section A, and we'll close Q1 in each bay, so both bays are included in bus bar 1A, and the other time we'll open Q1 and close Q2 for these two bays, so both bay units are included in bus zone 2A, and the same for bus B or section B for bus bar 1B and bus bar 2B. One time we'll close Q1 and the other time we'll close Q2. It's not important to do the test between every two bay units, only any two bay units, because this one, as we said, the slope test is common for the bus zone. So any two bay units you can use for this test. Our connection diagram will be as follows. This one is the central unit connected through fiber cable to the bay units, and this one our test kit, which is the Fraser. We'll inject here from phase R the current going to the first bay unit, and this one is the neutral, and from the yellow phase we'll inject here on the other bay unit and return it back to also to the neutral. Okay, so under stable condition we can say if we have two bay units, the two bay units or the two bays, Q1 is closed, it means one of them is source and the other one is a load, or if both are source or both are load, it means there is no current will pass. But if we have one source and one load, it means there is one of them will give the current, other one will draw this current. It means the angle between these two currents are 180 degree. So the stable condition is the angle between the two currents is 180 degrees. So I will inject red phase with angle 0, and from the yellow phase I will inject the same current but with angle 180 degree. It means both current are stable. So I will come back here to my table, AD05 and AD06. I will close Q1 in both of them, and I will inject on red phase, yellow phase, blue phase. Then I will change and close Q2, and I will check for bus zone 2A, bus zone 2A, bus zone 2A for red, yellow, blue. Okay, my stabilizing factor is 0.8. So what I will do, what's a value for I1 and I2, how can I calculate this one? Okay, it's very easy. You can as you can see here, Q1 is closed, Q1 is closed, and the Q2 is open. will inject red phase here, I1 with equal I1 angle 0, and I2 will equal I2 with angle 180 degree. And according to this one is our characteristic curve. Our IK minimum is 3000 and the slope is 0.8. And this one another curve which is slope is equal to 1. This one is the limit because this one is my operating area in this place. Why? Because if both currents are added together to the bus bar, it means the I differential in this case will equal to I stabilizing, and the slope in this case will equal to 1, but you will not find the tripping here. The tripping is maximum at slope equal to 1 and minimum is equal to your slope. So for example, we'll choose any point, for example at point number A. First I should know what's the limit of this IK minimum here, the start of the slope at I restrain 1. What's the value for this one? So the slope will equal K, I differential over I restrain number 1. So 0.8 equal 1 over I restrain 1. I restrain 1 is equal to 1.25. Then I will choose any I restrain more than 1.25, for example 2 ampere. Then at this point A, slope is equal K equal I differential 2 over I restrain 2. So I differential 2 will equal 1.6 ampere. I differential is equal I1 minus I2 because we said that we will inject I1 with 0 degree and I2 with 180 degree. But otherwise, if you will inject I1 with 0 degree and I2 with any other degree, 120, 130, 140, so you don't have to use this equation. You have to use the modulus of the summation of I1 plus I2, or you can say I1 as a vector plus I2 as a vector. But actually, because we are using 180 degrees, so it will be I1 minus I2. Okay, and I restrain is I1 plus I2. I1 minus I2 equal 1.6. I1 plus I2 is equal to 2 ampere. So I1 now is 1.8 and I2 is 0.2 ampere. This one is my calculated value. Okay, here he calculated by other way in the format. I don't care, no problem. So he choose I1 is equal to, for example, and I2 expected value is 0.22 for tripping. Or you can make the calculation as I told you here. You choose any value and you can get the I1 and I2. But let us check the format here. I1 is 2 and the expected I2 is 0.22. So what we are going to do, we'll inject I1 is equal to 2 ampere and I2 also is equal to 2 ampere with 180 degree. Then we will reduce I2 gradually until the contact is closed, which is assigned with the trip on giving me buzzer. At this value, I have to go to the measurement here, view protection zone measurement, and open bus zone 1A and check what's the value for the differential and what's the value for the restraint, and value for the differential and restraint as a primary, as you know, and you can calculate it by secondary values over 3000. You can divide these values over 3000, so you can get I differential and I stabilizing, and then you can get the slope. You will do the same for phase yellow, you will do the same for phase blue, and then you will open Q1 and close Q2 and do the same, but the measurement here will be included in bus zone 2A. The same will be for section B. This one for the slope of the bus zone. Now for the slope of the check zone. Actually, for the check zone, now at the final setting, the slope of the bus zone is 0.8 and the slope of the check zone is 0.2. So we cannot inject between only two bays, as the way we used to get the slope of the bus zone, because the relay will not trip if the slope of the check zone is achieved until the slope of the bus zone is achieved according to this logic. Bus zone characteristic and check zone characteristics must be achieved to get bus bar tripped, right? So if we inject only between two bays, even the slope is more than 0.2 of the check zone, the relay will not trip until the other slope of the bus zone will be achieved. So we'll do another way. We'll use another way. We'll use 3 pay units. We'll inject 2 pay units are stable like this way. I1 is going like that, or IA, you can say IA is going to this pay unit and coming back and go to from the other side of the bay unit. It means with 180 degree for the other bay unit. So these 2 bay units are stable, and these 2 bay units on one bus, Q1 is closed, here also Q1 is closed, and Q2 is open, and Q2 is open. So both of them are included in bus zone 1A. And I will inject on other bay unit which is included in bus zone 2A. Q2 is closed and Q1 is open. Okay, by this way, this one our connection diagram here. So by this way, we'll inject between these 2 bays as we said with 180 degree, and we'll inject on the 3rd bay unit. So if we open here again, this one our bus zone characteristics, and this one our check zone characteristic. Okay, for bus zone number 1, the current I1 will equal IA angle 0, and for bay unit 2 will equal also IA with an 180 degree. Here IA and here IA, but 180 degree. So in this case, I differential will equal summation of the vectorial sum of the currents, which is equal to 0, and I restraint equal to A. So this bus zone is stable, there is no tripping. For bus zone 2, I3 is equal IB. It means I differential is equal IB and I restraint is equal IB. So in this case, the slope is equal 1. Okay, more than 0.2, yes, but the tripping should be issued if the IB is more than IK minimum. What's the meaning of this one? It means you can achieve the slope here. Already slope is equal 1. It means in this one, but not more than IK minimum. So the slope must be achieved, and also the current should be more than IK minimum. The differential current should be more than IK minimum. So here I have to choose IB with a value more than IK minimum. For the check zone, the I differential will equal the summation of all currents. IA with angle 0, IB with angle 0, and IB and IA with angle 180 degree. It means equal IB. And for I restrain, the summation of currents, which is equal IA angle 0 plus IA angle 180, but the modulus of this one, and IB as a modulus also. So it means 2IA plus IB. So the slope here is equal IB over 2A plus IB. We'll choose here also one point, which is B, for example, but first I should to know I restrain 1 is equal how much. So slope, which is the slope of the check zone, equal I differential over I restrain 1, which is equal 0.2 equal 1 over I restrain 1. So I restrain is equal 5 ampere. Here this one 3000 means 1, and so this one will equal 5 ampere. Okay, at point B, I restrain 2, I will choose I restrain 2 is equal 6 ampere. At point B, slope equal 0.2 equal I differential 2 over 6 ampere, so I differential is 1.2. In this case, I differential, which is equal IB for the check zone, will equal 1.2 ampere, and I restrain, which is equal to A plus IB, equal 6 ampere. Because IA is equal 1.2 ampere, IB equal 1.2 ampere, so both IB here was 1.2 ampere, and you will get IA is equal to 0.4 ampere. Also IA, as noticed here, the value of IB is more than IK minimum for the bus zone, so the bus zone will trip at 1 ampere, and also this one more than IK minimum for the check zone already here available. This one I differential is 1.2 more than IK minimum, and at the same time should be more than bus zone. As you know here, for bus zone 1 it's already stable, no tripping. For bus zone 2, the value should be more than IK minimum to allow tripping of bus zone, and also I should trip the check zone. Already the check zone I get the value here on the slope, so it's already will trip for the check zone. But the value for IB, I have to check this one will allow the bus zone to trip. So it's already now it's okay, equal 1.2 ampere. So we'll inject on IA or I1 2.4 angle 0, and I2 2.4 angle 180 degree, and I3 with 0 degree, and then I will increase the current of I3 on the third bay unit gradually until the relay trips. So if we go here again, we'll find here, for example, he choose here I1 equal 2 ampere, and this one injected current here I2 bus bar 2A, this one's expected, and here this one is the actual. So here the I1 here between this bay unit 1 and bay unit 2 on the same bus bar will be injected with 2 ampere, and the expected value to be injected on bay unit 3 to give tripping is equal to 1 ampere, and this one is the measured value. I will increase the current here, I will make this one 0 and increase gradually until the relay trips. Then I will check the factor or the stabilizing factor, which is K, and the measurement of the differential stabilizing and the slope. I'll do the same test for L2 and L3. Here he choose any other values, no problem, you can do with the same value, there is no problem, but if you change it will be better.